Okay, we're back again. We're going to start out on looking at some of the system pictures, and here we'll go ahead and turn the lights off and get started right away. Okay. You know, we started out with this overall project looking at means of producing these animals in this production a lot more efficiently and competitively. And we wanted to try to combine some of the aspects of recirculating aquaculture with the lower cost of pond aquaculture using a river and a pond concept. Our objective, as we've stated here, is we wanted to get our fish survival up better than 90%, improve our FCR to less than 1.6 to 1, reduce our overall cost per unit of gain, and gain a much greater control over our inventory so that we can feed correctly. And we wanted to reduce the energy in production used so we could reduce that cost component. And certainly, even though we think we might have a lot of labor, it is still something that we want to try to trim any time we possibly can. And we want to try to be able to learn how to harvest and utilize production byproduct and resources that are part of the production scheme. So the original design was at Dean Wilson Farms or Butch Wilson's place near Browns, Alabama. The overall footprint, the concrete floor, this is what we call a fixed floor unit, is 100 by 40. We developed 6 raceways that are sitting on the pad, and we have paddles that push water through there and exchange the water about every 5 to 6 minutes. The paddles in this case turn about 1.2 RPMs, and we're able to effectively exchange the water very, very inexpensively. We have a waste collection system on the downstream end of the raceway right up under the walkway there that you see that helps us remove the waste any time of day or night that we program it. This is a schematic of the system. It's a 6-acre pond. The raceways are situated in one corner. This is not to scale now, but these raceways only constitute about 1/10 of an acre. And that's the only place in the pond that the fish are fed. There are other fish out here, filter feeding fish, but they are not fed at all. The only feeding goes on in the raceways, and the water is pushed around this baffle, and it has to come back through the water delivery channel there on the upstream end of the raceways. Our approach to feeding is to achieve a 1.6. We do not want to achieve fast-growing fish at the expense of a poor feed efficiency. But guess what? These fish do grow fast if we feed them correctly. Now, our feed allowance was based on fish biomass in the raceways and the average size of fish and water temperature. We've developed a little tool that helps us calculate that very, very accurately. Fish were sampled about monthly. It's not an obtrusive thing, doesn't cost a lot of money or a lot of time. But the emphasis was on inventory knowledge and control. And we were able to determine the size of the fish, and we were able to track what we thought that where we thought they were as to where they really were when we ground truth the data as we sampled it from the system. We were stocking in these original projects at about 10,000 per acre up to right about 55,000 per acre, looking at the system and how they performed. This is Butch over here. He was the original guinea pig, so to speak. But we put these fish in there, and whether they were at 10,000 or 55,000 per cell, the water quality in the cell deteriorated only slightly as it passed through the system. So even at the high levels of 55,000 per cell, the system performed very, very well. Over a 220-day growing season, I wanted to show you this part of the slide. We were able to achieve a total weight harvested at 109,000 pounds, the production of 69,000 pounds, and essentially we produced about 13,000 pounds per acre just in a 220-day growing cycle. If we had taken this on, we've shown since then we would have been at about 25,000 pounds per acre. Channel and hybrids together, we looked at mean survival of about 83%, FCR about 1.5 to 1. The channels didn't didn't do badly. We had one cell that was sick, and when they went in and they didn't get better, we were able to stop the disease, but the survivorship was relatively poor. Hybrids, we were at about 93% on the hybrid survival and about 75% on the channels. Water quality within the raceways and within the pond system was very, very good. In fact, it was more stable than any other pond on the farm. And the parameters that we were checking, whether it was dissolved oxygen, temperature, pH, ammonia, nitrite or nitrates and whatnot, were very, very healthy environment for the fish. This is a simulated model that pushed these numbers forward that Dr. Hansen put together. You can see the channel catfish. We're looking at about a 1.7 FCR, and the hybrids were a 1.36 FCR. Again, at quite high production levels, just again over a relatively short production window. In our initial summary here on these fixed floor systems, the design modification, we needed to continue work on the waste removal system and produce advanced fingerling so that as soon as we harvested one group out, we can put another group in there and we get very, very good efficiencies. And we can probably get, if we stock fish that are in a third of a pound, quarter pound to a third of a pound, we should be able to get 2 crops out in a season. Again, this is reality. Next step is again to run this system with these bigger stockers so that we can go over a longer period of time, and that we've done some of that since this was done, since this slide was produced, so we're much further along than we were. Okay.